Good morning, gentlemen. Today we are going to finish up our discussion of Chapter 9 on centripetal force and talk about one practical example that we really haven't discussed in the past. All right. First and foremost, remember that centripetal force is a force that causes an object to travel in a circular path. And so things like tension in a string that you're whirling over your head, all right, that the string is providing a tension force, and that tension force is actually, in that case, providing a centripetal force. The force of gravity between the Earth and the Sun, all right, causes the Sun to move in a circular path. And of course, the friction between your tires and the road, that frictional force allows you to drive your car in a circular path, or at least around a curve. All right. All three of those examples provide a centripetal force. Okay. Another practical example that we have not considered thus far is that of simulated gravity. Now, not actual gravity here, but a simulated gravitational force. You've all seen images on the news or wherever of astronauts in space that are just kind of, floating around and right through their spaceships, because obviously out in space there is no, at least no strong force of gravity to keep them on the floor of their spaceships. Okay, and so that's all fine and good for short periods of time, a couple of months or maybe even a year. But studies have shown that there are health effects to living in a weightless environment for that long. And so what we have to do if we ever want to travel great distances to other planets in our solar system or even perhaps beyond is to figure out a way how to simulate gravity. It turns out that this is where centrifugal force might actually come in. Now remember, centrifugal force is a fictitious force, but you still feel like you're being pushed outward in a spaceship. And so any space station or any ship that's traveling long distances through space is going to have to rotate in some way in order to simulate gravity. Okay? One of the things that's wrong with science fiction movies like Star Trek and Star Wars is that you end up with a spaceship that's traveling through space, all right, and they all stay perfectly flat and they face each other just like a battleship on the surface of the ocean. Well, that's not reality. Okay? In reality, there has to be a way to simulate gravity on that spaceship to keep these folks going and traveling in an actual move. And so, in order to do this, what we'd really have to do on Darth Vader's spaceship here is to have it rotate at a certain rate, fast enough so that it generates a centripetal force that keeps all of the passengers in that ship on the ground, if you will. Okay, and so there has to be a rotation. Captain Kirk in the Enterprise, Darth Vader on the Imperial starships, and all those kinds of folks would actually have to be spinning in space in order to keep standing on the floor. There has to be a simulated gravity routine. Now, again, there's some nice pictures in your textbook of what a space station like that might look like. And there are some movies that have given a fairly accurate depiction of simulated gravity, right? Spaceships that have portions that rotate in order to simulate this gravity. So keep that in mind. Now, for homework this evening, I would like you to do the review questions for Chapter 9, numbers 11 through 18. They will be due at 2:30 this afternoon via email. I will post instructions on Blackboard right under this video, or in the text here on the topics day for today, March 25th. Tomorrow, March 26th, you will have a quiz on Chapter 9. Okay? The quiz will be administered at your class time. All right, whether it's the beginning of first period or the beginning of second period. You'll then I will post the quiz at your class time. You will then have 30 minutes to reply to me via email with your answers. All right, and then I'll grade them and we'll move on from there. All right, I'll put more written instructions on our Blackbaud page.